Good evening. Am I audible there?
Yes, ma'am.
Yes. Yeah, thank you. So we'll be starting with the transportation problem. So transportation problem, it's a typical problem of LPP only. Okay, in the form of LPP, we can actually write the black here of the board. Yeah, like in the case of LPP, we can also solve transportation and assignment problem by by formulating a model. Like we have an objective, we have constraints. Okay, so typically what do you mean by transportation is we have our factory units at different locations, okay, throughout the geography, and we have our warehouses, that is the display units, in the different locations. Okay, so our problem is, as the name implies, transportation problem is we have to transport the products, raw material, or whatever it is from certain places, from the supply units to different demand units, from the supply units to different demand units. So we have several supply units. Supply units are typically the factories. Okay, the factories, you can all go to transportation problem, please. Okay, so supply units are factories. So we can have number of factories. You can have only one factory, you can have several factories, you can have several factories, and you will have, is my screen visible to everybody?
Yes, yeah.
Yes. Okay, and we have warehouses. Okay, warehouses are the demand points. Okay, so the demand. Okay, so based on the different locations of geography, factories and warehouses, our problem would be to solve the typical transportation problem. Okay, so factory one will have certain demand. Okay, so the factory one's demand is say 50 units. Okay, factory two's demand is say 100 units. Supply is 100 units. So in factory two, we are manufacturing 100 units. In factory one, we are manufacturing 50 units, and in factory three, we are manufacturing say 50 units. Okay, so now the total supply is 200 units. Okay, and then warehouse are the demand points. So warehouse are demanding. We have different warehouses in different locations. Say warehouse one is in Delhi, warehouse two is in Chennai, and warehouse three is in Pune. Okay, so these are the three distribution centers we have, and the factories are located in say Hyderabad. Factory is located in Bangalore. Factory is located in say some other location, maybe Bhopal. Okay, so we have factories in different locations and we have warehouses in different locations. So our problem is we have to meet the demand of the warehouses. So warehouses are posing demand. Okay, and factories are giving you supply. Their manufacturing is being done in the factories. Okay, and warehouses are the demand points. So warehouse one is demanding some units, warehouse two is demanding some units. Say warehouse one is demanding 125 units. Okay, warehouse two is demanding say 20 units. 20 units only. Chennai is demanding only 20 units. Okay, and warehouse three, Pune's warehouse is demanding say 55 units. Okay, so our point is, after solving the problem, we should be able to tell from Hyderabad to Pune, how many units are you supplying? From Hyderabad to Chennai, how many units are you supplying? From Hyderabad to Pune, how many units are we supplying? So this is our typical problem. Okay, and in this matrix, in this cells, from Hyderabad to Delhi, from Hyderabad to Chennai, these are known as the individual cells. Here, this will be given, cost will be given, the transportation cost, the unit transportation cost. Suppose 5 is mentioned here, means how do you read this is to transport one unit from Hyderabad to Delhi, one unit, we incur 5 rupees. That is what it means. Okay. So the matrix will be given to you, and the demand and supply of different warehouses and different factories will be given to you. What you have to find out is, see, we have to meet the demand. We have to meet this demand 125, 20, 55. We have to meet the demand, and we have to exhaust the supply. Okay. So how many units from which factory you are sending to which warehouse? So that is the typical solution. We find out solution at 2 levels. First, we find out the basic feasible solution. Initial basic feasible solution. That is what it is known as. We find out initial basic feasible solution, and then we find out, we improvise it further. Okay, we improvise it further by optimizing it. Optimizing it. Okay, so initial basic feasible solution we find out first. Feasible solution. What do you mean by feasible? Feasible is nothing but practical solution. Practical solution. Can I suppose we are planning to have a conference in our college? Okay, can I have it on February 30th? Is it feasible to have it on February 30th?
No.
No, because it doesn't exist. It is not practical, isn't it? Yes. So feasible solution is nothing but the practical solution. Okay, here the practical solution is, yes, I can send from Hyderabad. I am meeting the demand. I'm meeting 125 demand of Delhi, 20 demand of Chennai, 55 demand of Pune, and I'm exhausting the supply. So feasible solution is one where I'm meeting the total demand. I'm meeting the total demand. Okay. Yes, it is practical. Okay. And I'm exhausting the supply. This is the feasible solution. Okay. But it may not be the optimal solution. So here, if you think about linear programming problem, what would be your objective function here? Is it to minimize or maximize? Is it to minimize the cost, transportation cost, or to maximize the transportation cost?
Minimize.
Minimize.
Transportation cost. Sometimes in this matrix, instead of transportation cost, profit figures will be given to you. Means if I transport one unit from Hyderabad to some other location, I get 10 rupees of profit. Okay. In that case, our optimization will take the meaning of maximization, because we want to maximize the profits there. Okay. But unless otherwise mentioned, you should treat that the whatever figures are given in the matrix are only transportation cost. Is that clear? Yes.
Yes.
Yes. Okay. So transportation problem, whatever methods are there for finding out the initial basic feasible solution, actually there are only 3 methods, but in your material, if you see, there can be 5 methods given. Okay. So first method is northwest corner method. Northwest corner method. Okay. Second method is least cost method. Okay, least cost method. Third one is Vogel's approximation method. Vogel's approximation method. Vogel. It's named after the person who has given the method. Okay. Least cost method. Least cost method. And this is northwest corner method. Northwest corner method. These 3 are the methods. But in your study material, it is least cost method is again divided into 2 methods. They call it as row minima method, column minima method, column minima method. These methods you can see always. If you understand the basic logic, you can understand any method. Okay. So we will start with finding out the feasible solution in today's class. Following up, tomorrow we will try to optimize it by using 2 different methods. Okay. So feasible solution is, yes, it is feasible. Okay. We are able to meet demand. We are able to exhaust the supply. It may not be the least cost solution. Okay. So we try to improvise it further by trying to reallocate some of the units from one transportation to other things, so that we get the feasible solution. Okay, so you can go to your study material to page number. I may not be able to share it. I'll be able the material also because it is evening. One minute. So go to my material. Yeah. Transportation problem is on 101 page. So you can go to, yeah. Initial basic feasible solution is in page number 105. Okay. So here he has given one thing. We have 3 plants, S1, S2, S3, S4. And 4 supply units and 5 warehouses are there. Okay. So, John, erase. Are you there in that page? It's there in
Yes,
page
ma'am.
number 106. Page number 106, please. You can go to page number 106. We are solving the northwest corner method. Okay. Yeah, now I'll tell you the steps. Please, you can note it down in the book. Okay. Yeah. What do you check first is you have to check the step one. Step one. Okay. Whenever you see a transportation problem, you have to check whether it is a balanced problem. Sorry. Yeah, balanced problem or unbalanced problem. Okay, unbalanced problem. Right? Yeah. So what is balanced problem? Balanced problem is one where total demand equal to total supply. You can note down that. Okay, whether total demand is equal to total supply or not, you have to check. So in that page number 106, they have given supplies of 4 different factories, plants. So supply of first plant is how much? If your material is open, can you tell me?
60.
60. So total supply we will see S1 plus S2 plus S3 plus S4. How much is the total supply? 60 plus 20 plus 20 plus 50.
150.
150. How much is total demand? M1 plus M2 plus M3 plus M4 plus M5.
150.
150. So this is a balanced problem. Suppose in case if it is an unbalanced problem, what we have to do is we have to make it balanced and then proceed to step 2. Okay, just remember, if it is not a balanced problem, if it is an unbalanced problem, you have to make it a balanced problem. Suppose let us make this problem only unbalanced. Suppose supply is 160, demand is 150. So what is falling short? Demand or supply?
Demand.
Demand.
So we have to create a dummy warehouse. Dummy warehouse. Is that clear?
Yes, ma'am.
Yeah, which is demanding 10 units. We have to create a dummy warehouse. Okay. If suppose supply is falling short, we have to create a dummy factory. Is that clear? How do you make the unbalanced problem into balanced problem?
Yes,
By creating dummies.
By creating a dummy. Okay, so dummy is something which is not existing. Okay, so to supply to a dummy factory, supply from a dummy factory to a actual warehouse, will you incur anything cost? No, right?
No, ma'am.
Will you incur any cost? So in the dummy thing, we have to enter all zeros. Okay, is that clear?
Okay.
Yeah, and then go ahead with the problem. Okay, so that is how we convert the unbalanced problem into balanced problem. So step 1 is convert, if check for balanced problem or unbalanced problem. If it is a balanced problem, you can go to step 2. If it is an unbalanced problem, make it a balanced problem and then go to step 2. Okay, is the step 1 clear?
Yes,
Yes.
ma'am.
Yes. Okay, now step 2. Step 2. Step 2 is check whether the given problem is maximization problem or minimization problem. Okay. You have to check whether it is a maximization problem. You can please note down. Check whether it is a maximization problem or minimization problem. Okay. What do you mean by minimization problem? You have to decide. Okay. If suppose in the matrix they don't mention anything, you assume that the whatever values are given in the matrix are cost, transportation cost. So you want to minimize the cost or maximize the cost?
Minimize the
Minimize. So in that case, it is a minimization problem. Okay. So you can go to step 3. But if it is a maximization problem, you have to change it to minimization problem. Okay. Suppose in the matrix, if they give the figures and they say that these figures are profits. So what type of problem it is? Maximization or minimization?
maximization.
Maximization. But we can't solve transportation problem using maximization problem. So what we have to do? Maximization problem, we need to convert that into minimization problem. Then only we have to go ahead. Is that clear?
Yes, ma'am.
Yes. Okay. So now we will take up, we'll go to step 3. Step 3, whatever method is given, if they ask to find out the feasible solution by using northwest corner method, we have to do it by northwest corner method or least cost method, whatever method it is there. So we'll take up one problem today and we will solve it by all the methods. Okay. So feasible solution, we will be able to finish it. These methods are quite easy. Even if you go through the material later, also you will be able to understand on your own, because step-by-step process nicely they have given. Okay. So now let me draw this matrix. Okay. Yeah. So there are 4 plans: S1, S2, S3, S4. Okay. And there are Johnny in the line at Korea. Dabba drop and please. This erase pan first. In the dabba.
Sir.
This male warehouse at the table length. Pero it. One, 2, 3, 4, 5. 5 bodo. Either 6 venu vertical. 5 bodunda. 6 panne.
Vertical again.
Vertical 1, 2, 3, 4, 5, 6. 6. இது eraser யூஸ் பண்ண முடியுமா இல்ல இப்போ இதுக்கு போனோம்னாக்க இதுக்கு போக முடியுமா நான் yeah 5 7 10 8 4 yeah, this is what is given. This is for S1, S2, S3, S4. He has drawn one extra. Yeah. Okay. Then M1, M2, M3. So this is the problem given to you. Total. Okay. These are the unit cost. Unless otherwise mentioned, you have to treat it as unit cost only. Okay.
Okay.
Yeah. And these totals are 60, 20, See, you need not get confused between 60. You need not add 5 plus 7 plus 10 plus 8 plus 4 are 60 or not. That is different. Those are unit cost and these are units, number of units. Okay. Yeah. Yeah. Step 1. Is it a balanced problem? Is
Yes.
total demand equal to total supply or not?
It is equal.
Is it equal?
Yes.
Yes. If it is not equal, you have to make it equal by creating a dummy factory or dummy warehouse. In this case, it is equal. Second step, is it a maximization problem or minimization problem?
Minimization.
Minimization problem. See, you have to follow the sequence. First, check for balanced, then go for maximization or minimization. You can't reverse these steps, please. Okay. So now usually minimization problems only will be given to you. Okay. So now let us solve it by northwest corner method. If you see the directions, north is this, west is this, isn't it? Yes.
Yes.
Yeah. So this becomes a northwest corner, isn't it? This is northwest corner. Yes.
Yes.
Yes. So northwest corner becomes this S1 M1 cell. So here we have to allocate some units. Okay. So we have to see simultaneously demand and supply. How much is S1 producing? How many units?
60.
60. But is M1 demanding 60 units?
No, ma'am.
No, it is only 30. So whichever is less, you have to allot here. Okay. 30 means from S1 factory to M1 warehouse, we are transporting 30 units. It means that. Is that clear?
Yes.
Yes. So
Ma'am,
now,
can you repeat once?
yeah. See, S1 is producing 60 units, isn't it?
Yeah.
Yes?
Yes, yes.
Yes. But how much is M1 demanding?
30.
30. So will S1 say that, no, I have produced 60, I will supply entire 60 units to you? It can't say that, right?
No, only 30.
Yeah, it will supply only 30 units to M1. Is that clear?
Yes.
Yes. So this M1's demand is met, isn't it?
Yes, ma'am.
Yes. Yes. So I'll strike off this column. Okay, with a pencil, you can strike off in your books. I can strike off the first column because the demand is met. Is that clear?
Yes.
Yes. Now we will come to this supply. Out of 60, 30 is over, no?
Oh, yes, ma'am.
Isn't it?
Yeah.
Yeah. So how much is left now?
30.
30.
Yeah. So write down 30. 30 is only left. Yeah.
Yes.
Yes. Now S1 with S1 factory 30 is left. So can't it supply it to M2?
It can, ma'am.
It can. So write down 30 here. Why I'm writing 30 is M2's demand is 40, isn't it?
Yes.
M2's demand is how much?
40.
40.
40. So can't I supply 30 from S1?
Yes.
Yes, I can. Now, isn't S1's factory's entire produce got exhausted?
Yes,
ma'am.
it got
S1. Yeah, S1 is empty now. I will just strike off S1. Okay. I will strike off with a pencil. Is that clear?
Yes.
Yes.
So S1 has produced 60 units. Out of 60 units, it is transporting 30 units to M1, 30 units to M2. Is that clear?
Yes, ma'am. But required is 40, right?
Required is 40. We'll come to it. Okay. So out of 40 demand, 30 is met. How much more is to be met?
10.
10. So write down 10 here. Yes, is it clear so far?
Yes, ma'am.
Yes.
Yes. Now we will come to S2 now. Okay. So from S2 to M2, can't we supply 10 units?
We can.
We can. So write down 10.
10.
Why I'm writing only 10? S2 is supplying, can supply 20. But how much is M2 requiring? Only 10, isn't it?
10. Yes, ma'am.
Yes. So I'm supplying 10 units from S2 to M2. S2 to M2, I'm supplying 10 units at the rate of 9 rupees. At the rate of 9 rupees per unit. Transportation cost is 9 rupees. Is it clear?
Yes.
Yes. Is M2's demand met?
Yes.
Yes,
ma'am. 30
Yes.
plus.
So please strike it off with a pencil. Okay, some authors, what they do is after every allocation, they draw a new matrix. Okay. So anything is okay. It will, this way, it will save your time. That's all.
yes.
It's a matter of understanding. Okay. If it is fine with this, it's fine. Now for me, I have to draw another matrix. It will be a waste of time. Okay. Yeah. Now in S2 factory, out of 20, how much
10.
units are
10.
gone? 10. So 10 are left over still?
Yes, ma'am.
Yeah. Now we will come to S2 M3 cell. How much is M3's demand?
20.
20. But how much is S2 can supply now?
10.
10. So allocate 10. Allocate 10. Is that clear?
Yes, ma'am.
Yeah, from S2 to M3, we are supplying 10 units. Now S2 has become empty, isn't it?
Yeah.
Yeah, strike off S2. And M3's demand, how much is met? M3's demand, 10 is met. How much more is to be met?
10.
10.
10. So write down 10 here. Now you tell me now, which cell should I come?
M4.
S3 and
M3S.
M3.
very good. S3, M3. See, we are slowly moving from northwest corner only, isn't it? We have started from here. We are coming diagonally, meeting slowly, seeing demand, supply, and we are allocating, isn't it?
Yes.
Yes. Okay. So shall we come here? S3, M3?
Yes.
Yes.
Yeah. How much can I supply here?
20.
10 or 20 we can supply.
Is 20, but demand is only 10.
Only 10.
Yes.
Only 10. Okay. So only 10. Now M3's demand is completely fulfilled. I will strike off this. Okay. M3's demand is met. I will strike off that. How much supply is left over in S3 now?
10.
10. So write down 10 here. Now to which cell should I come?
Yes,
S4, M4.
S3, M4.
S3, M4.
S3, M4. Very good. Okay. To S3, M4, how much can I supply?
10.
10.
10. Very good. 10. Right. So which supply got over or demand got met?
Supply got over.
So remove off S3 now from your chart. Remove off S3. How much demand is still to be fulfilled of M4?
20.
20.
So write down 20 here.
S4, M4, 20.
Very good. S4, M4, 20. 20. So which demand got over or fulfilled or supply got over?
Demand.
Demand. Which demand? M4's demand got fulfilled. Strike it off. Now, how much supply is left over here?
30.
30.
30. 30. So can't I supply from S4 to M5 30 units?
Yes, ma'am.
Yes, I can Oh,
Oh. Oh.
yeah. See now, all the demands are met, all the supplies are exhausted, isn't it?
Yes, ma'am.
Yes.
Yes, ma'am.
You can quickly write down the feasible solution. From S1 to M1, you are supplying 30 units at the rate of 5 rupees. So how much is the cost? Make a transportation bill. 150, isn't it?
150. Yes, ma'am.
Yeah. From S1 to M2, you are supplying 30 units at the rate of 7 rupees. So how much? 210.
210.
Yeah, then S2 to M2, you are supplying 10 units at the rate of rupees 90 rupees.
9.
Okay. Then S2 to M3, you are supplying 10 units at the rate of 60 rupees. Then S3
S3.
to M3, you are supplying 10 units at the rate of 120 rupees. Okay. S3 to M4, you are supplying 10 units at the rate of 9. How much? 90. Then S4 to M4, you are supplying 20 at the rate of, is my entire screen visible?
At the rate of 7.
7. Is my entire screen visible?
Yes.
Yes,
Yeah.
ma'am.
Please make a transportation bill little clearly. I'm not able to use this pen properly. It's not coming neat. But you make it a neat bill. Okay? Yeah. Elder. S4 to M5. S4 M5. Yeah. S4 M5. 30 units. 30 at the rate of how much?
3.
3 or 13?
13. It's
13. 390 rupees. Isn't it?
Yes, ma'am.
Yeah. Can you tell me the total cost? 150 plus 210 plus 90 plus 60 plus 120 plus 90 plus 140 plus 390.
1250.
How much, sir?
1250.
1250. Okay. 1250. Is that clear? Yeah?
Yes.
Yeah. Now the same problem. I will just skip row maxima and column maxima because least cost method is more superior method than those two. So same numerical will solve by least cost method. Isn't it? Okay.
Okay.
Okay. And we'll see how much we are saving on the cost. Okay. So it is funny table. Full delete பண்ண முடியாது. Full sheet.
ಮೊತ್ತ ಅಲ್ಲ
ಇದು 5/6 the matrix 5/6 rows 5 columns 6. Okay. Quickly. Yeah. தெரியாதுடா. 5/6 rows 5 ఇలాగంటే 6/6 పని ఉన్నావు అవ్వదు. ఇంకా ప్రాబ్లం ఉంది అక్కడ. One, 2, 3, 4. Vertical. Yeah. Next, we'll move by least cost method, and you will certainly see that there is an improvement over the cost. Okay, I'll quickly write the numbers here. 5, 7, 10. See, please, you have the M1, M2s are there with you. So 8, 4, 7, 9, 6, 3, 5, 20, 10, 11, 12, 9, 6, 20, 4, 6, 10, 7, 13, 50, 30, 40, 20, 30, 30. Thank you.
Another.
Yeah. Yeah. So is this clear? This table is seen?
Yes,
Yes.
ma'am.
Yes. Now what we'll do is we will try to identify. See, this northwest corner method didn't had any logic. We just started off with northwest corner and we went on allocating. See, without even seeing whether it is a least cost or not. Okay. Now tell me, which is the least cost? Is it 4 rupees, 5 rupees, 7 rupees, 9 rupees? Which one is the least cost?
3 rupees.
Yeah.
3, ma'am.
3. So we'll come to this cell. We'll come to this cell. Okay. So now here it belongs to S2, isn't it?
Yes, 2 M4.
S2
4.
M4. Okay. So M4's demand. How much is M4's demand?
30.
30. How much is S2 supply?
20.
20. So how much I can allot in this cell?
20.
20 or 30?
20.
20. Very good. So allot 20 here. So what I'm doing, I'm going to the least cost cell. I'm allotting as much as I can there. As much as I can. If I can allot 20, I will allot 20. If I can allot 30, I'll allot 30 there. Okay. So how can I determine whether how much I can allot? I have to see the demand and supply. Supply is 20, demand is 30. So I will supply only 20. Isn't it?
Yes.
Yes. Is it clear? I went directly to the least cost cell and allotted there. Is it clear?
Yes.
Yes. So is the supply got over or demand got over?
Supply got over.
Supply.
Supply.
So I will just strike off this line. Supply got over. You see, it reminds me that I need not touch that factory now. Okay, that's why I am erasing it off. Means I'm striking it off. That's all. Okay. Now, how much of demand is yet to be fulfilled here?
10.
10.
10.
10.
Write down 10 here. Okay. Now, after 3, from the unstriked off cells, which is the least cost now?
4.
4.
4.
We have 2 cells
M1.
here. Right? Yeah, there is a tie. Okay, so whichever 4 I can allot maximum, I will go and allot there. To this 4, how much I can allot? 30 or 50? How much?
50.
30.
50.
But demand is only 30.
Yeah, 30 we can.
30. In which
I have
this
to.
cell, how much I can allot?
30.
30. I will allot in
30.
both. Okay, so I will allot 30 here. I will allot 30 here. Okay. So, which one got over? Demand or supply?
Demand.
Demand got met. So I will strike off demand. Okay, how much of supply is left over still?
30.
30. So write down 30 here. Okay. Next, can I come to this 4 again now? I can.
Yes.
Yes, yes, ma'am.
Yes. So I will allot 30 here also. Okay. Yes.
Yes.
Why 30, ma'am?
Sir, these 2 are independent. I'm going from least cost. I allotted in this 4 cell and this 4 cell also I can allot 30 because demand is 30, supply is 50, isn't it?
Yeah. Okay. Yeah.
And I allot, yes. So this demand got over, no?
Yes,
Yes.
ma'am.
Please strike it off. How much of supply is left over?
20.
20.
20. So write down 20 here. Yeah. Now, next least cost.
6, ma'am.
6.
6. So I'll come to this cell now. How much I can allot? 20 or 40?
20 we can.
20. Only 20 can
I
be
will
moved.
allot 20 here. I will allot 20. Okay. So now demand got over or supply got over?
Supply.
Supply got over. Please strike it off. Supply. Okay. How much of demand is yet to be met?
20.
20. So write down 20 here. Yeah. Next least cost, please.
7.
7.
Then I will come to this cell. How much I can allot here? 20 or 30?
20.
20. So I will allot 20. Which got over? Supply or demand?
Demand.
Demand. Strike off the demand. This warehouse demand got over. How much supply is left over now?
10.
10. So write down 10. Next least cost, please.
9.
8, ma'am.
8. 8 is also there. No? 8 is there. Can I come to 8?
Yes, ma'am.
Yes. So here, how much can I put? 10 or 10? 10.
10.
10.
It is have any confusion. Okay. So simultaneously supply is also over.
Demand.
Demand also.
Is also over. Next least cost. Only one cell is left
12.
over now.
12. 12.
I don't have any choice also. I will allot 20 here. Okay. Demand got over. Supply got over. Everybody is happy now. Isn't it?
Yes, ma'am.
Yeah. So let us write down now. Let us write down whatever allocations we have done. S1, M2. S1, M2, 20 at the rate of 7.
40.
How
40.
much is the cost? 140. 140.
Yes, ma'am.
S1, M4, 10. 10
At the rate of 8.
at the rate of 8.
80.
80.
80 rupees. 80. S1, M5. S1, M5, 30 units
At the rate of 4.
4.
20.
20 rupees. Then S2, M4, 20
3.
at the rate of 3. 60. S3,
M3.
M3, 20 at the rate of 12.
240.
40.
240 rupees. Then S4, M1, S1, S4, M1, 30 at the rate of 4.
120.
120. S4, M2, 20 at the rate of 6.
120.
120. Please find out the total. Most of the cases, I don't say all the cases, but most of the cases, there is a saving in the cost.
880.
How much?
880.
880. 880. Okay. How much was the before cost?
1250.
Is this solution better or that one better?
880 is better, ma'am.
880 is better.
880.
So, yeah. So, this method is better than northwest corner method because northwest corner method, we don't have any logic. We just move on from northwest corner and keep on allocating. Okay. Least cost method, there is a logic because we are going to the least cost and allocating there as much as we can, isn't it?
Yes, ma'am.
Yes. And now the next method, row maxima and column maxima, they are similar to least cost method. I am very confident that you will be able to understand it if you go through the material. Okay. So what in row maxima, what you do is, you will go to first row. Which is the least cost in the first row?
5. 4.
4.
4.
You will allocate there. Okay. Then you come to second row, third row, fourth row, like that. Okay. Is that clear?
Yes, ma'am.
Yeah. And in column minima method, what you do is you go column wise. First column, which is least cost,
4.
4. You allocate there. Second column, which is least cost?
6.
6. You allocate there. It's like that. Okay?
So he should
Is that
get the supply total or demand total.
no, sir. Always for any allocation, you should see the demand and supply. That's all. As a layman, also, if you think, you will see how much is the demand, how much is the supply, and you will supply accordingly, isn't it?
Okay, ma'am.
Okay. So you can see the material. They have solved it beautifully step by step. You can go through that. Okay. Yes.
Ma'am, one small question. In
Yes,
this,
sir.
like we need to allocate until all the columns and rows are struck off.
Yes. Okay. So total of 150 units should be allotted. Okay. If you count here 20 plus 10 plus 30 plus 20 plus 20 plus 30 plus 20, it will come to 150. See, you should exhaust all the factories and you have to meet all the demands, isn't it? It's your business. Okay. You have to see that everybody is happy. All the demand points are happy and all the supply points are exhausted. Okay. And that too in a least cost possible. Least cost possible. Even if I prima facie, if I take this, I will go for 880. Okay. I won't go for the 1250 solution earlier.
Yeah.
Okay. Shall we go to the third method?
Yes.
Yes.
Yeah. Johnny, erase palita. Tin more draw palita. Okay. So for Vogel's approximation method, what I suggest is you should draw the table on the northwest corner of your paper book. Okay, northwest corner. So that I want some space below for working and I want some space on the right. Okay. Draw a table here. India draw. And kilo on the right place.
Ma'am, at examination point of view, all the methods will be asked or any particular method.
Don't know, sir. I haven't checked your paper, but maybe that was as a teacher. Maybe I am bound to teach you everything.
Yeah,
But
sure.
if methods are there, Vogel's approximation is the best method. It will be very closer. The solution, what you get by Vogel's approximation method, it will be very close to the least cost, means the optimal solution. Okay.
Thank you.
Yeah.
Mm,
India, table. इनके placement में इनको 6 columns, vertical 6, horizontal 5. You should leave some space on the right and you should leave some space below. Okay. Six, 1, 2, 3, 4, 5, 6. It's the horizontal 5. Thank you. Yeah, please. You have drawn. You have entered the table in your books.
Yes, ma'am.
Yeah. Yeah. So this is dependent. This is based on the premise of opportunity cost. Okay. Opportunity cost concept says that the loss. You must have learned it in your economics, isn't it? What is opportunity cost? Opportunity cost is the cost which you bear because you haven't chosen the best option, but the next best option. Okay. So in the first row, which is the least cost? First row, which is the least cost?
Four.
First row, 5, 7, 10, 8, 4. Horizontally is row.
Okay.
4.
4. Suppose if I don't allocate in 4, but if I allocate in the next least cost, how much more cost I have to bear?
1.
1 rupee. Very good. So write down 1 here. D1 stands for difference. Difference 1. Okay. So least cost, next least cost. Suppose if there are two same costs are there, then the difference will become 0.
0.
Okay? Yeah. In the second row, which is the least cost?
3.
Is by the second one. Second one, which is the least cost?
3.
3. Next least cost?
5.
5.
5.
2.
So difference is 2. Very good. 2. Third row.
6.
6.
6 and
9.
9. Difference
3.
is 3. Yes. Write down 3. Fourth row.
4. 6.
4.
6.
6. 2.
Yeah, difference is 2. Right. 2.
Yes.
Come to first column. Okay, how much is the difference?
1.
1. Second column.
1.
1.
1. Yeah.
Yeah. Third column.
4.
4.
4. Fourth column.
4.
4. Fifth column.
1.
1. See, what are these 1, 2, 3, 2, 1, 1, 4, 1 is? They are the penalty you have to pay if you are making a mistake. Okay. I'm not allocating here in 4, but I'm allocating in 5. How much penalty I have to face? It is the
1.
cost of my mistake. Cost of my mistake is 1. Cost of my mistake is 2. Cost of my mistake is 3. Cost of my mistake is 2. Cost of my mistake is 4.
4.
Now tell me which mistake I want to avoid first.
4.
4. Very good. Okay. So, but I have 2, 4. Isn't it?
Yes, ma'am.
Yeah. Now I will avoid a mistake there. Okay. In this 4, it belongs to the third column. In this, which is the least cost?
6.
6. Now in this 4, in the next column, which is the least cost?
3.
3. See, there was a tie in this 4 and 4. Okay, I have to break this tie. Okay. So how do you break the tie is you go to that column and see for the least cost and go to the next column, see for the least cost. Now I have to allot in 6 or in 3. Which one do you choose? You tell me now.
3, ma'am.
3. Very good. So choose this 3. How much do we allocate here? 20 or 30?
20.
20.
20. Very good. So I will allot 20 here. Is that clear?
Yes, ma'am.
Yeah.
Yeah. See, we have found out opportunity cost. Then highest opportunity cost I want to avoid, but there was a tie there. How do I break the tie? In least cost cell, I have to allot. Is that clear?
Yes.
Yeah.
Yes. With this 20 allotment, which got exhausted? Supply or demand?
Supply.
Supply.
So please strike off this. Okay. And how much demand is left over still?
10.
10.
10. So write down 10 here. Now, whatever things are left over now, we have to again go on with D2 now. Difference 2. Difference 2. In the first row, what is the difference? Same.
Again, same.
Again, least cost, next least cost. 1.
1.
1. Next row, it's not applicable. Okay, put dash here. Third row,
3.
3. Fourth row,
2.
2.
2.
Now, first column. Now for column, we should ignore this 7 now. Okay. One which is trigraph, we should ignore that. Okay, which is the
One.
difference between
1.
second column,
1.
1.
third column.
4.
Now you should ignore 6, please.
10.
What is the next, please?
It's a tie.
10.
2.
It's a time. No,
No, no,
it's
10.
not.
0.
10 minus 10 is 0, isn't it?
Yes. Ma'am, we have only 1 minute left. Ma'am.
Yeah. Can't I extend this?
It is automatically disconnected.
Yeah, automatically disconnected. Can I join again?
Yeah.
Yes, we can.
Yeah.
Yes, sir.
I think I'll join again. Okay?
Okay. Okay.
We'll finish off this numerical, don't worry.
Sure,
Okay?
sure.
Yeah. See here in the third column, least cost is 10. Next least cost is also 10. 10 minus 10 is how much?
0.
0. In the fourth column,
1.
1.